Good afternoon, everyone. Thank you for joining us. We have a lot to cover today, so we're going to get started and stay on schedule. Next slide, please. Welcome, everyone, to the Domestic Critical Minerals and Materials Supply Chains Workshop. We're very happy to have all of you with us for the next couple of hours. My name is Carson DuPont, and I'll be serving as a moderator for this event. I'd like to take just a moment to cover some housekeeping items. I first want to highlight that this event is being recorded and may be posted on the DOE website or used for internal DOE purposes. All attendees will be muted throughout the event, but I'll mention the Q&A function in a moment. A little bit later, I'll be introducing a link to the Microsoft Forms platform to gather this input, which of course is voluntary and optional. DOE's purpose today is not to build consensus. DOE's interest is in organizations' individual perspectives. There is a Q&A function. You'll find this in the top toolbar of the Teams application on your screen. This will be open throughout the workshop. Questions will not be answered live, but DOE will make available an FAQ document to address the most common questions that attendees share today. The Q&A function will also be used to share links and resources throughout the event, so please keep an eye out for those updates. Finally, a recording of this event will be posted on DOE's YouTube channel in the coming weeks. Thanks for letting me get those notifications out of the way. Over the next couple of hours, here's what we plan to cover. I will share in the next slide the Microsoft Forms information. We will go through a brief introduction of our workshop presenters. We'll then hear from our DOE office overview presenters, presentations between 5 and 10 minutes in length. Following those presentations, we'll have a brief Q&A session based on questions already submitted. We'll then hear from 2 additional presenters, both for DOE-funded projects. Then a final brief Q&A with those 2 presenters, also based on questions already submitted. And then we'll close out the event. We should be on track around 2 p.m. Eastern Time. This is the information for the MS Forms page that DOE will use to gather your input on questions throughout the event. Again, this is completely voluntary. The link will be available 48 hours following the event. You can use the QR code depicted on the slide or by putting the details for the link in your browser. We'll keep this up for a moment, but the link will also be shared in the Q&A box. Again, you can access the Q&A code via the toolbar at the top of your Teams application. I will now mention our speakers for the next portion of the event. You will hear from each of them individually after this brief introduction. Kicking us off will be Wells Griffith, the Undersecretary of Energy at the Department of Energy. Next, we'll hear from Mike Kopp, a Senior Advisor to the Secretary of the Department of Energy. We will then hear from the following DOE leaders: Jennifer Schaefer, the Associate Director for Technology and Program Director within the Advanced Research Projects Agency Energy, commonly known as ARPA-E. Helena Kazduzian, the Critical Materials Collaborative Co-Lead and Senior Technology Manager in the Office of Energy Efficiency and Renewable Energy, Advanced Materials and Manufacturing Technologies Office, or EERE-AMTO. Ryan P., the Deputy Assistant Secretary for the Office of Resource Sustainability within the Office of Fossil Energy and Carbon Management, or FECM. Angelos Kokinos, Director of the Office of Manufacturing and Energy Supply Chains, or MESC. And Wadad Whitman, the Acting Deputy Director for Battery and Critical Materials within MESC. We will also hear from 2 speakers outside of DOE who will provide presentations on projects that are DOE funded. Paul Boniface, Director, Business Development, Rare Element Resources, and Frank Johnson, Chief Technology Officer, Niron Magnetics. We will now hear from our first speaker. As mentioned during the introductions, Wells Griffith III serves as the Undersecretary of Energy at the Department of Energy. He has previously served in other roles at DOE, including the Principal Deputy Assistant Secretary and Acting Assistant Secretary in the Office of International Affairs, and as DOE's Senior Advisor to the White House. He has also served under President Trump's previous administration as Special Assistant to the President and Senior Director for Energy Environment at the National Security Council and National Economic Council. Over to you, Undersecretary Griffith.
And thank you for that introduction, and welcome everyone to today's workshop. When it comes to critical minerals and materials, the challenge we face is plainly evident to all of us who are here today. Simply stated, we must break free of our dependence on certain foreign sources. 50 years ago, our nation faced a similar problem when it came to oil and gas. That's ultimately one of the reasons that what led to the creation of the Department of Energy in the first place. Our Department of Energy went on to play a pivotal role in unlocking American energy and innovation. But it was only under President Trump's first administration that we finally produced enough energy ourselves to become independent of foreign sources for our everyday needs. Under President Trump's direction during his first term, we strengthened our energy security, advanced our economic security, and bolstered our national security. Presently, we face a similar challenge regarding the critical mineral and material supply chain situation. We don't have the luxury of dithering on their production or development here at home. We must meet the moment today. Every part of today's society depends on critical materials, and the foreign adversaries who produce them are weaponizing them to our detriment. The good news is the return of President Trump is the best thing that could have happened on critical minerals production and supply chains and for strengthening our national and economic security. The same President Trump who made us energy independent is equally determined to break the stranglehold our adversaries have on critical materials and rare earth elements. From the day he was inaugurated in January, the president has quickly delivered a range of presidential actions, including 4 executive orders that make the production of critical materials a serious priority of his administration, and that is critical to the American energy dominance agenda. What the president's directive amounts to is a firm mandate not to hunker down, not to consume less, not to trim our sails, but to rise up, get moving, and get the job done. Just like we've done on oil, gas, coal, nuclear, and every other energy source we produce and consume. So what specifically can and should we do to advance the president's mandate to shore up domestic supply chains of critical materials? Well, in the form of both virgin material and secondary sources, our nation has abundant resources and innovative technologies to move this ball forward. Secondary sources such as mine tailings and e-waste are potential recycling feedstocks, which can jumpstart critical mineral and rare earth element production in the United States. In addition, the Department of Energy can form near and midterm R&D collaboration with our incredible national labs and industry on advanced mining techniques, advanced mineral processing, advanced substitute materials, processes that increase the efficient use of materials, and other innovative solutions, which we plan to discuss today. Just last Wednesday, we at the Department of Energy took a major step forward on all of this, making a breakthrough announcement of our intent to issue notices of funding opportunities or NOFOs, totaling nearly $1 billion to support this priority. The 5 planned NOFOs will support our domestic supply chain at all critical levels by providing opportunities for developing technologies, commercial scale deployments, and recovery materials from byproducts and waste streams. A strong American industry is the best defense against our adversaries. Under President Trump and Secretary Wright's direction, the DOE plans to use the tools at our disposal to support our industries whose innovation and productivity is unmatched. The big picture is this: we must break free as a country of any bias against production within our nation's borders. We should never apologize for our modern way of life or our abundance of natural resources. Instead, we should celebrate it and what it has done to unleash prosperity across our great nation. Our adversaries certainly aren't apologizing, and if we are to break free of them, we can't either. So once again, thanks for coming. Let's make today a productive one to advance the president's energy dominance agenda and secure a resilient, critical minerals and materials supply chain. Thank you.
Thank you very much, Undersecretary Griffith. We will now hear from Mike Kopp, the Senior Advisor to the DOE Secretary.
Well, we'd like to once again welcome you and thank you for joining us for our workshop today. My name is Mike Kopp. I'm a senior advisor to the Secretary, and I've been tasked with coordinating the department's critical mineral strategy, the central pillar of which is to secure the American critical minerals and materials supply chain. In a few minutes, you will hear overviews from some of our program offices whose work focuses on critical minerals and materials. Before we hear from these offices, I would like to just make a few comments about the purpose of our workshop. DOE is taking a multifaceted and comprehensive approach to accelerating the growth of the U.S. critical minerals and materials sector. We have established a Tiger team called the Critical Minerals Working Group to harness the expertise of each of our program offices engaged in the work and to align our efforts toward the objective of securing the critical mineral supply chain. Each of the offices you'll hear from today represent key stages of critical minerals and materials supply chains that advance and scale the mining, processing, manufacturing technologies that are foundational for U.S. energy dominance and global competitiveness. Our program offices bring distinct sets of technical expertise to the critical minerals supply chain discussion, and they each focus on a different aspect of the supply chain. You'll hear from the Advanced Research Projects Agency for Energy, ARPA-E, which focuses on advancing research and development with private sector sponsors. Concerning applied R&D, we have the Office of Fossil Energy and Carbon Management, which in the context of critical minerals principally focuses on extraction and processing. We also have the Office of Energy Efficiency and Renewable Energy, which has a strong focus on the manufacturing of engineered materials and component manufacturing. And last but not least, the Office of Manufacturing and Energy Supply Chains, MESC, focuses on the next stage of the supply chain, demonstration and deployment. These offices and more across DOE are working together to help build resilient, stable, and secure supply chains for critical materials. Without their help, we cannot achieve a resilient, stable, or secure energy sector, and that's why we're all here today. This work, the work of building a secure supply chain, is expressly directed by the President, as expressed in numerous executive actions. In Unleashing American Energy, he directs the government to establish our position as the leading producer and processor of non-fuel materials, including rare earth minerals, which will create jobs and prosperity at home, strengthen supply chains for the United States and its allies, and reduce the global influence of malign and adversarial states. We take that charge very seriously, and we are going to move as quickly and smartly as possible to carry out this directive. In our time today, we hope to leverage the public-private synergy in this space. So ahead of this event, many of you submitted questions. We synthesized some frequently asked questions, which our DOE speakers will address during our Q&A session. Throughout the workshop and in the days following, we'd like you to provide your input to key questions via our feedback form, which Karsten highlighted earlier. If you missed that slide, there are directions in the Q&A tool on how to access the form. We're also interested in hearing your questions you have for us. Although we won't be taking live questions, we encourage you to ask questions throughout the workshop using the Q&A tool. We will compile the most frequently asked questions into an FAQ document. The insight we receive today will help inform DOE's strategies and programming in both the short and long term for critical minerals and materials. So thanks again for joining us today. I'll now turn things back to Karsten to kick off our DOE office overview presentations. Thank you.
Thank you very much, Mike. We'll now begin a series of presentations from the range of relevant DOE offices that Mike just referenced. Kicking off will be Jennifer Schaefer, Associate Director for Technology at ARPA-E.
Thank you so much, Karsten, and thank you everybody for being here today as we cover the significantly important topic of critical minerals and how we can advance this within the Department of Energy and with your partnership. Today, I will be giving a bit of an agency overview, since it is always helpful to understand exactly how and why ARPA-E supports the efforts that we do. as well as I'll talk about specific technologies and specific areas that we're thinking about focusing on with respect to our remit here. Next slide, please. ARPA-E was really initiated around 2007, where the National Academies of Sciences published the report Rising Above the Gathering Storm, and this warned policymakers of the U.S. advantages in science and technology had began to erode. And the American Competes Act was signed that authorized the creation of ARPA-E to basically manage the reality that our competitive advantage had began to erode. The American Recovery and Reinvestment Act was signed in 2009, which appropriated its first funds to ARPA-E. And when you look at over the course of more than 15 years of effort with the agency, we've now funded more than 1,700 awards. We've had 87 focused programs, more that I'll be discussing today. And in general, we are funded at the level of several $100 million per year. Next slide. ARPA-E focuses on a full ballast of challenges that connect to American competitiveness. So this can be things related to resilient energy infrastructure for the 21st century. You'll see many intersections here where we focus on American competitiveness, looking at American-made energy for all, U.S. economic development, really focusing on American leadership in science and technology. Of course, we have emphasis and consideration related to energy-related emissions, as well as significantly improving the efficiency of our energy-intensive processes in a way that can have significant impact with respect to our energy leadership within the U.S. Next slide. One really critical facet of ARPA-E is thinking about how we can take early stage technologies and advance them through the capital stack towards commercial deployment. ARPA-E exists in a space where focused programs focus on particular risk dynamics, and these risk dynamics can focus on technological risk, commercialization risk, and other pieces such that we can move pieces forward through to commercialization. In this very high risk area, what you can see is that you might realize startups being formed, or you might realize that university and national labs are coming to the table with respect to technologies that they're interested in spinning out into companies, or even licensing these technologies forward. As you continue down that pipeline and you move through the de-risking process, you'll recognize that it's important to bring greater and greater sources of capital to the table to continue this advancement and commercialization. In some instances, technology is well positioned for direct investment from the private sector, and this can relate to venture capital or other ways to move this forward. But sometimes things are still a bit too early stage for private investment, and that's part of why we've developed the ARPA-E scale-up mission. And generally what you'll see with respect to ARPA-E programs is average program size will be on the order of $3 to $4 million, with cost shares from 0 to 20%. However, with ARPA-E scale-up, you'll see projects on the order of $5 to $20 million with cost shares up to 50%, as we really focus on advancing through the commercialization, beachhead markets, etc. Next slide, please. When we look at what we've funded in the past to date supporting critical minerals and materials, you can see that this is something that ARPA-E has been considering ever since its early inception, with things like the REACT program that focused on rare earth alternatives to critical minerals. And we funded efforts like MINER to improve the energetics associated with beneficiation. We have focused programs in circular, where we think about right at the beginning, we think of the end in mind, such that we can improve manufacturing processes such that they can minimize the need for recycling and improve disassembly and reassembly. Phytomining is another effort that we have funded in the agency, where we look at the hyperaccumulation of nickel and other critical minerals in plants to improve that separation and energy intensiveness of those processes, as well as the speed to deployment. The efforts that I'll be talking about today are newer efforts that are on the street or potentially available for further consideration. These are efforts like the RECOVER program, which I'll be speaking more about, as well as potential new research areas like rocks and magneto. We, of course, have a couple of scale-up efforts in this with Niron, who you'll be hearing from later, as well as core power magnetics, where we're really focusing on technology here that can obviate the need for critical minerals in our energy sector. Next slide, please. The first effort that I'll speak more about is the recover effort, and this is a significant focus on recovering 100% of key critical metal supplies and 50% of domestic ammonia supplies by recovery from wastewater sources. What we recognize is that a significant component of energy intensiveness in our critical mineral supply chain is the ore crushing and beneficiation associated with this. There's a very unique opportunity to leverage our wastewater resources where critical minerals may exist in concentrations sufficient for their recovery, and to partner already with the fact that these are materials have been functionally beneficiated in a way. One of the reasons why we believe that this is a very timely and appropriate investment to make is because there have been significant advances in membrane technologies as well as electrochemical separation technologies that are well positioned to manage the complex matrix effects that arise from wastewater, as well as the reality that frequently the analytes and ions that you're trying to target are at lower concentrations than what you might identify in other critical mineral resources and more conventional ones. And so the efforts here will focus on, of course, stabilizing American supply chains, and teams will be developing new materials to selectively target and recover ions and molecules from wastewater. With this, the new approaches always have commercialization in mind, and we'll be looking at their scalability to large operations and complementing existing wastewater treatment needs such that we can minimize the capital investment and advance and accelerate deployment. Next slide, please. Another potential future effort that we're considering is the Magneto program, where this would design and develop powerful magnets to improve energy efficiency, reduce the cost of electricity generation, and enable smaller, lighter motors. The reality is we know that motors use more than 40% of generated electricity, and all motors depend on a spinning wheel of magnets to drive this electricity. We also know that there have not been significant advances in magnetic technology since the development of neodymium-based magnets several decades ago. And it seems that there is a very ripe opportunity with the development of AI and machine learning methodologies to, especially in the materials space, to go ahead and advance what this technology could actually look like in the future. We also have a much deeper understanding of the physics at play and some of the chemistries that are relevant here, and those are modeling efforts as well that could help advance our development of novel magnetic materials. You can see that we have aggressive targets in mind with respect to the BEH max for permanent magnets being up to 800 kilojoules per meter cubed, and the B saturated for any magnets up to 2.5 Tesla. And the idea for this being that if we could develop significantly stronger magnets, we might be in a position where we can significantly minimize critical mineral dependence because of the more powerful energetics associated with these types of materials, or we could be in a position where we obviate the need for rare earth materials at all. And so this is what we're seeking in this effort. Next slide, please. Another potential future program that we are considering is the ROCKS program, and this would really accelerate U.S. mineral independence by increasing long-term U.S. access of rare earth elements and other critical minerals. This actually builds on a previous effort that RPE collaborated with DARPA and USGS, where we leveraged the significant capability and resourcing already that existed with the USGS with respect to our known mineral resources, leveraged AI and machine learning capabilities to improve the resolution of maps and provide more geologic features and better accuracy, potential accuracy of what these types of resources could look like. What we're thinking about as we advance this effort is we would like to take it further than just leveraging the resources that we already have with the USGS, but actually doing validation of that modeling and advancing it such that we can do 3D, basically deep underground assessment of what mineral resources would look like. And this is something that could rapidly accelerate our ability to translate resource to reserve with respect to these types of materials. You can imagine in order to do that, we need to support transformative innovations in drilling, sensing, analytical technologies, etc. And we really need to do this to assure long-term dominance of domestic U.S. reserves. Next slide, please. And this was what I had for our webinar today. I'd like to turn it over to Karsten so that we can continue to advance through our exciting agenda.
Thanks so much, Jen. Next, we will hear from Helena Kazduzian, the Critical Materials Collaborative EERE co-lead and Senior Technology Manager in the Advanced Materials and Manufacturing Technologies Office.
Thanks so much, Carson. So I'm really excited today to present about EERE's critical materials and minerals efforts. I just want to QR code here. If you want to subscribe to our email list, you can stay up to date on all of the great work we do across the entire program office. Next slide, please. So EERE is really an applied research office. In the space of critical minerals and materials, we do work across all the 4 pillars of our critical materials strategy at DOE, where we really emphasize materials to manufacturing as well as management at the end of life. We also lead the critical materials assessment for the department, which is underway. And thanks to all of you who may have contributed, we had a really nice, robust response to that. One of the areas we really focus in across this space is on highly efficient midstream to downstream processing. And particularly in the midstream, we do partner with our colleagues in the Fossil Energy Office, which you'll hear from next. We also drive the development of many of the energy technologies that are dependent on critical minerals in a very intensive way, like electric vehicles. And so we have a unique approach in EERE where we can pair our innovation approaches to critical materials with the technology development and really develop product innovations that reduce our demand on these critical materials and also drive the reuse and recycling at end of life, since we work so closely with those industries. So this is done through our different technology offices on advanced materials and manufacturing technologies. That's where my home office is, as well as geothermal, hydrogen and fuel cells, solar, wind, and vehicles. Next slide, please. All right, so EERE is a really integral part of the broader DOE innovation ecosystem, and our role really is innovation, right? We're trying to drive globally competitive supply chains in a couple different ways, right? We want to make sure the technologies, the materials, the processes that we develop are cost competitive, right? And we can do that through efficiency improvements and process intensification. We can also make sure that we facilitate a social license to operate by making sure those technologies are environmentally benign. That's really important when we think about the trajectory of commercialization. And of course, we can't do this in a vacuum, right? So we do a lot of this work through public-private partnerships, which is really what's shown here at the bottom of this slide. They really are our secret to success, and we have quite a few lab-led consortium. One is the Critical Materials Innovation Hub, which I'll talk about more in just a moment. But I do want to highlight here the Resource Center, which is a collaboration of industry, academia, and national labs working together to advance recycling technologies along the entire life cycle for batteries, both current and future chemistries. While I'm just touching on batteries, I do just want to highlight our Advanced Battery Consortium that's run through EERE's Vehicle Technologies Office. There's probably not a lithium-ion battery chemistry on the market or a electric vehicle that wasn't developed through this consortium. I think that just is such a testament to the power of these public-private partnerships and how pairing this innovation on critical materials with the technology development and for energy is really powerful. We have many more programs that are developing innovation, which I'll just touch in a second. We also are thinking about facilitating multiple pathways to foster commercialization of those technologies, like the accelerator program that's represented in the middle of this diagram, that's supported by techno-economic analysis and workforce development, and of course, the power of our national labs. But we really can't do any of this without people, right? So that's where workforce comes in. I'll talk more about some examples of that in a moment. And of course, we partner with all of the other offices on this webinar now to think about those different pathways to commercialization. Next slide, please. So here is just a flavor of what EERE's programs look like, right? This isn't comprehensive, but I just wanted to kind of get a flavor, right? So you can see on the left some different programs through our different tech offices. And they touch on all 4 of those strategic pillars I mentioned, right? And a range of different critical materials. So we have, a lot of work on lithium extraction from geothermal brines. We're looking at platinum group metal substitutes and also e-waste recycling, just as a flavor of these different technologies. And it gives, I think, some insight into what our funding priorities have looked like to date. Next slide, please. All right, so one program I do want to highlight is the Critical Materials Innovation Hub. It was launched in 2013 as the flagship program to really advance DOE's first ever critical materials strategy. That's really reflected in its organization. You can see that on the left, where the core research areas are aligned with our strategic focus in DOE on enhancing and diversifying supply, developing substitutes, and also unlocking secondary sources. All of this research is accelerated through the use of cross-cutting research, and this is really an early stage effort to develop technological options. The ecosystem brings together 9 national labs, 20 universities, and over 20 companies to do this work. It is industry-informed but science-led, and it's been very successful. You can see it's resulted in over 60 patents and 20 technologies licensed to industry. Many of those are working their way to become, commercially available today. And just this week, SEMI added actually 2 new R&D 100 awards to its name. First, I want to congratulate the director, Thomas Lagrasso, for being named the R&D Leader of the Year. It's a really great recognition, and we're excited, that our labs benefit from his leadership. Ames National Lab also received an R&D 100 award as being a Green Tech Gold winner. So that's for rare earth metal via alternative fluoride salt process that was developed actually through CMI, and is a new way to make metals for rare earth elements. So this is just a sample of the power of this hub. It's a really strong R&D foundation that's being expanded, especially by our colleagues in the Office of Fossil Energy, which you'll hear about shortly. Next slide, please. I just want to highlight a few ways that we're training the workforce in DOE at EERE. So our Vehicle Technologies Office has several workforce development activities and battery recycling, aiming to develop secure mineral supply chains by taking advantage of minerals already in the battery supply chain. On the engineering side, our students work with the Battery Workforce Challenge Competition to compete design modules for ease of recyclability. And you can see an example of that on the upper right. We're working to develop standardized training curricula for technicians at battery recycling facilities. So you can see it's not just academic focus, it's also thinking about the broader needs. We have in my home office in AMTO, the Lab Embedded Entrepreneurship Program. That's providing fellows who have early stage startups or technologies with support to basically learn how to transition their ideas into the market. Over 200 fellows have been supported. They're managing over 100, almost 200 businesses as well. That's created over 4,000 jobs. And several startups that focus on critical materials have gone through this program, like N-Cycle. CMI itself is doing quite a bit to meet the moment. Over 1,000 alumni have come out of CMI and gone to industry. About 35% of those folks go into industry like MP Materials, Energy Fuels, and Tesla, but also going to our national labs, university, and even government. I myself am an alumna of CMI and bringing that expertise here to the Department of Energy. We also have some programs that have benefited, the broader ecosystem of our national labs by training through our Leadership Academy, leveraging our great fellowship and internship programs like the Science Undergrad Laboratory Internship. And then we also think about not just K through 12, but actually K through 16, thinking about undergrads. How are we training them to be the next generation of leaders? Sorry about that. This summer, CMI actually launched their own internship program that's increasing industry access to the national labs, capabilities and equipment. It's providing more confidence to industry in hiring these students by working with them directly. And it's also addressing a need, right? Students need this training with industry in mind. CMI also has an education toolkit that's being used by our current cohort of the CMI Leadership Academy. You can see on the bottom left, that's them learning how to use the toolkit. They're deploying this all over the country in their hometowns and at the high schools in their area to help young people learn what critical materials are. And then finally, CMI's educational lead, the Carlisle School of Mines, mentors students all the time. You can see on the bottom right, this is the 5th year in a row that CMI as partner with the Colorado School of Mines to mentor a team. The Colorado State High School Engineering Design Competition went to the national competition for the 5th year in a row. So that's a way we're training this new generation. Next slide, please. Okay, and finally, the moment I think everyone's probably waiting for is about the notice of intent that went out on August 13th. It signals the intention for AMTO to fund a critical minerals and materials accelerator program at a level of up to $50 million. The goals of this program are to foster industrial partnerships to prototype and pilot innovation and validate these materials and manufacturing technologies so we can boost demand, extend the lifetime of the materials. We also want to enable informed decisions, optimize the processes, and build confidence in the scale up of these technologies by leveraging life cycle assessment and techno-economic analysis. And finally, we also want to address the urgency of the moment, right, to meet the demand, to secure these supply chains, and have the technologies and manufacturing needed. It's expected to cover 4 areas of interest you can see on the slide. So rare earth magnet processing from secondary sources, refining and alloying of semiconductor materials, direct lithium extraction and separation, and improved co-production. The teaming partner list is active. You can see the QR code on the right. That'll bring you to the notice of intent announcement. This is a way for you to, express your interest and explore potential partnerships. But just a quick disclaimer that joining the list does not mean that DOE has endorsed or sponsored those individuals or organizations on the teaming list. So just providing that disclaimer. And that's all I have. So I'll turn it back to Karsten. Thank you.
Thank you very much, Helena. Next, we will hear from Ryan P., Deputy Assistant Secretary, Office of Resource Sustainability in the Office of Fossil Energy and Carbon Management.
Thank you. So the Office of Fossil Energy and Carbon Management supports the development, production, processing, transportation, and use of our nation's vast natural resources, including minerals, natural gas, oil, and coal. My office is focused on the production and processing phases of the critical minerals and materials supply chain. So next slide. Our office funds research and development through grants and other financial assistance that can be deployed in American industries to increase U.S. competitiveness and secure production of domestic natural resources. As I'm sure many of you know, the biggest mines in the world are American mines, and the world's largest maker of mining equipment is an American company. It wasn't so long ago that American industry led the world in the processing and production of graphite, aluminum, and rare earth elements. We believe the U.S. will win this race for resource security by leaning into our industrial strengths and our industrial innovative spirit. We've done this before. This is the office that invested in the early research and technologies for hydraulic fracturing and directional drilling, then partnered with industry to ignite the shale revolution. And we can do it again. Innovation and helping industry do new things is our specialty. Next slide. So to overcome the critical minerals crisis, we need to both mobilize immediate private sector solutions to address urgent national security and economic threats, and invest in innovations that leapfrog foreign competitors to secure long-term stability. Each critical material supply chain has unique challenges, but to win the long game, we will need to make sustained R&D investments to pioneer new processes and de-risk emerging technologies. These breakthroughs are essential to lowering supply risk and reducing the energy system's dependence on vulnerable critical materials. At the same time, DOE is intensifying efforts to deliver immediate impacts that mitigate today's critical minerals crisis while building the foundation for lasting resilience. Next slide. So these are the areas where the Office of Fossil Energy will make strategic and long-term investments. Our office focuses on mineral production and processing technologies to produce the minerals we need from wherever they can be found.
This includes prospecting technology for new mineral production opportunities, developing new ways of mining, new materials, and very important for today, deploying technologies to recover minerals from American industrial processes. Our office works closely with the private sector to increase the likelihood of technologies reaching the marketplace at scale. In alignment with our office's strengths and the spirit of advancing mineral addition, we need to address gaps in mining, workforce, and mineral supply. Our office will ignite industries to compete for unminable mineral resources by investing in technologies that can transform mining, similar to how the shale revolution changed the economics of oil and gas extraction. To develop a robust domestic mineral industry, we need to enact measures to support the current mining and metallurgy workforce, enable crossover from engineers and technicians in other sectors into critical minerals, and stimulate a new generation of workforce interested in all elements of the supply chain. Next slide. So after over a decade of successful program activity, there are immediate impacts we can deliver from our technology development. We believe new technologies are ready to scale critical mineral recovery at existing industry operations, and this will generate new supply as a byproduct of major industries. We believe new businesses can deliver high-impact tonnages that matter from domestic industries like oil and gas, the power sector, and other major industries like zinc, aluminum, titanium, and fertilizer. In addition to the benefits of delivering immediate impact, this can lead to stable regional supply chains that are robust to foreign manipulation because they're fortified by other domestic commercial sectors. That is why we have released a notice of intent to fund $250 million in mines and metals pilots, partnered with industry. We anticipate to release the funding opportunity this calendar year. We will be seeking applications for pilot-scale critical minerals and materials recovery facilities, and we will award $10 to $50 million per facility for the design, construction, and operation at a domestic location. These applications will need to be based on bench scale or prototype processes that have been demonstrated using actual feedstocks on at least a semi-continuous basis. And we are looking for applications from coal-based industry and other industries like power generation, oil and gas, specialty metals, and basic materials. So please review the NOI and take actions so that you are ready to apply when the funding opportunity is released. Next slide. So speaking of things that you can do now, I encourage all organizations participating on this call to take the survey for the Critical Minerals and Materials Matchmaker, or CM3. This is an online information resource created to help connect users across the critical minerals and materials supply chain. The survey is designed for organizations to self-identify their critical minerals and materials aligned activities and interests, and an interactive map that displays those ongoing activities in a dynamic way. The goal of this tool is to connect organizations and individuals involved in research and development, demonstration, and deployment, as well as organizations that have activities related to critical mineral resource permitting, production, supply chains, and environmental impacts and benefits. The more organizations that take the survey will make the tool more effective and of benefit for all of you. Next slide. So the critical minerals crisis requires everyone working together and pulling in the same direction. And so I want to end by highlighting one effort we have with the national laboratories. Our office has built a team of lab experts and invested in the facilities and equipment to assist the department and U.S. industry to address this challenge. And we refer to this investment as Metallic, the Minerals to Materials Supply Chain Research Facility. It is an innovation ecosystem made of a consortium of 9 national laboratories. This will serve as a hub of experts and an equipment testbed for industry and academia. Metallic is a publicly accessible hub for scaling up infrastructure and technical assistance. It'll enable investors to focus resources on their core technologies and scale faster, ultimately accelerating innovation across the sector. And I want to underscore that Metallic will be available for use and partnership with anyone in industry and academia to accelerate the deployment of their technologies and new processes. We must work together with urgency to advance our national security and scientific interests for critical minerals and materials. Thank you for your time today.
Thanks very much, Ryan. For our attendees, just another brief note that you can find a number of helpful reminders, updates, and links in the Q&A section, which you can access from the top of your Teams application. Thank you. Next, we'll hear from Angelos Kokinos, Director, Office of Manufacturing and Energy Supply Chains, or MESC.
Good afternoon, everyone. I'm pleased to speak to you today about the significant role that the Manufacturing and Energy Supply Chains Office plays in the domestic critical minerals and materials supply chain. As you have heard so far, the Department of Energy has a comprehensive strategy to address critical materials and mineral challenges, spanning research and development, resource assessment, and international collaboration. With this broader effort, the Manufacturing and Energy Supply Chains Office plays a distinct and crucial role. We take the materials through the final step, commercial implementation. Our office's mission is to enhance economic and national security by eliminating vulnerabilities in the energy supply chain and expand our nation's energy production. We do so through 3 basic pillars. Number 1, catalyzing and manufacturing for energy resilience and dominance by co-investing with the private sector to ensure domestic manufacturing and competitiveness. In other words, assist in the commercial implementation of technologies. 2, reinvigorating our manufacturing workforce through education and training. And 3, guiding funding decisions and policy formulation through analysis and data-backed, market-focused supply chain insights. As you well know, critical minerals touch every part of our everyday lives, from the seatbelts that protect us while we're driving, to the MRIs that help assess our health, to the batteries that our cars, cell phones, defense systems, and laptops depend on, to the steel used in our bridges and jet engines, to the hard drives that keep our data centers and AI centers analyzing and delivering the information that we need. We have been tasked by the taxpayers to provide close to $10 billion in securing America's energy future by deploying energy manufacturing capacity, enhancing workforce development, and eliminating our vulnerabilities in the energy supply chain. Currently, we have over 300 initiatives that are being financed to advance these tasks. What does the commercial implementation mean in practice? While other offices, as you have heard within DOE and across the government, focus on foundational science, geological exploration, early and mid-stage technology development, we are dedicated in translating this advancements and strategic missions into tangible, scalable commercial realities. We understand that this is a capital intensive and often industry and often faces market uncertainties. So our office works to mitigate this risk through various mechanisms, including grants, technical assistance, and making domestic projects more attractive to private investment. This means that we support large-scale and demonstration projects, fostering public-private partnerships and identifying and resolving bottlenecks in the supply chain. Our goal is to support the industry by demonstrating the technical, and I emphasize that, the technical and economic viability of technologies at a commercial scale. Our approach is holistic, not only looking at existing or new advanced technologies that take things from critical minerals from what I call dirt to product, but we also look at recycling. Recycling is not merely waste management. It is a vital source of secondary supply that reduces reliance on the primary extraction. As a result, we also support demonstration of innovative recycling technologies. We're also aware that a strong domestic supply, as you have heard, requires a skilled workforce. So we are working in investing in training and education, and that is necessary to develop the resources that we need in the manufacturing and processing sector. In closing, our manufacturing and energy supply chains office is committed to its role as the commercial implementation arm, working very hard to ensure that the United States has the domestic capacity to meet its critical needs. We look forward to your continuing collaboration with all of you gathered today, and as we try to collectively build more resilient and secure domestic supply chains for critical minerals and materials. Thank you very much.
Thanks so much, Angelos. And finally, we'll hear from Widad Whitman, the Acting Deputy Director, Batteries and Critical Materials for MESC.
Good afternoon, and thank you all for joining us. To conclude the program overviews, we want to highlight the national security lens that we are applying at DOE. The Foreign Entity of Concern program, or FEOC, decouples our supply chains and ensures that taxpayer dollars go to American companies. The American energy industry cannot be beholden to foreign economic statecraft instruments, which is why we have invested significantly into building out an expansive FEOC strategy and program. That said, American companies also have a responsibility here, and that's to ensure that they are free from foreign influence and control. Our program will monitor state actor capability and intent, and strictly enforce national security standards as both a prerequisite and condition for maintaining those awards. You can find more information on FEOC guidelines in the QR code on the screen, or you can email the address below should you have additional questions. Thank you.
Thanks so much, Widad. And thank you to all of our presenters. We'll now shift to a 15 to 20-minute Q&A session with the presenters from whom you've just heard. They'll be answering questions previously submitted by many of you in attendance. And the first question we have is for Angelos Kokinos. Angelos, how will MESC engage with industry to ensure funding opportunities are relevant, support domestic manufacturing competitiveness, and address critical supply chain gaps?
Thank you. A couple of things. As it was mentioned earlier by both the Undersecretary and Mike Kopp, the Senior Advisor, the Secretary has tasked us to ensure that we coordinate our activities. And as a result of that, we have, under Mike Kopp's leadership, what we call the Critical Minerals Working Group, or TIGER Group, that ensures that meets every week, and that assures that every office that is working in critical minerals is informing as to their activities, such that we match the activities with what the goals of the President and the Secretary are. In addition to that, we have the Critical Minerals Collaborative Group, which is also meets regularly to coordinate on a regular basis to ensure that we have a cohesive approach to engaging with industry and what we are working on. Last but not least, the Manufacturing and Energy Supply Chains Office, we engage with industry through requests for information. We do webinars such as this, or in-person workshops, and in terms of, so we can hear directly from the stakeholders their ideas and their concern. We are very focused on commercializing the technology that is being developed, or to help address issues that the industry is facing as they are competing against foreign, what I would call monopolies. Thank you.
Thank you very much, Angelos. Elena Kazduzian will take the next question. Elena, what are the perceived bottlenecks for scaling up critical mineral technologies, and what support can AMTO provide for pilot scale projects and advanced separation techniques?
Thanks for that question, Karsten. I hear constantly from our stakeholders that they just need an opportunity to de-risk the projects. And this needs to be done on an industrial relevant scale, on a continuous basis, right, under real world conditions. And that's the scale might vary depending on the technology, but we hear consistently we just need this opportunity, right? And the pathways historically have been kind of limited, right? Like we do the R&D, there might be there's been a gap, right, to actually de-risk these technologies. And so that's partly why we created the Critical Materials Collaborative, right? We want to coordinate, of course, what we're doing, but we also want to facilitate multiple pathways for technology to get commercialized. And so, while we have our public-private partnerships that have the right teams in place, they need opportunities, right? So historically, we've had things like the Small Business Technologies Transfer Program, Office of Technology Commercialization's Technology Commercialization Fund Program, for folks for industry to partner with the labs, right, and scale the technologies. But now we also have this Critical Materials Accelerator Program that I mentioned earlier to kind of provide an additional pathway to validate technologies and really get them ready for piloting. And I think I'll just speak a little bit out of my office space for a second. You heard also from Ryan P. earlier on Metallic. That's open for collaboration, right? And this is really the ecosystem we have at our national labs, all of these capabilities under one roof, right, to do the de-risking, all these test bed configurations. So I think, we always welcome more feedback on how we can make these pathways more accessible. So please, reach out to us, to tell us what you need. But to my knowledge, that's what we have going on at the moment. Thanks.
Thank you, Helena. The next question is for Jen Schaefer. Jen, what strategies or funding pathways does ARPA-E envision to accelerate the transition of early stage, non-equilibrium, or low chemical input separations from laboratory to pilot scale validation and industrial adoption within the U.S. critical minerals supply chain?
That's a great question, because technologies like they're talking about there are going to be really critical, and they're a very ripe opportunity with respect to investment in de-risking. And so we do have further program development efforts going on at the agency. In my role as Associate Director of Technology, I work with program directors on the development of program areas. And depending on where we end up with our engagement with various stakeholders, anytime we develop a program, we interact both with the technology, engagements with universities, national labs, other aspects to understand the current state of the technology, as well as where the opportunities are with respect to business development and commercialization. And I imagine that coming forward, we're going to be looking at this very seriously as a part of engagement in that effort. And then if we were to move in that direction, I should also say that this is actually something that we do for all programs, right? But in the sector that you're particularly thinking about, you could imagine a potential focused funded program in this. And if that were to happen, that would be basically step one with respect to technological de-risking. And of course, from there, you could imagine marching through the ARPA-E technological de-risking pathway that I was talking about earlier, which is really start de-risking the technology, move forward with potential follow-on venture, or perhaps further non-dilutive investment from the Department of Energy to invest in that and go from there. So thanks for the question.
Thank you, Jen. Our next question is for Ryan P. Ryan, there's a renewed emphasis on extracting resources from the earth to accelerate our energy production. Will there be an increased emphasis on using the extracted materials and waste as an important source for domestic critical materials?
Yeah, thank you for the question. I mean, we have vast resources in the United States, both in the ground, in the subsurface, and located in these waste streams like mine tailings, coal ash, acid mine drainage, other industrial waste streams. And this is a huge opportunity and something that we see as a priority. Just like recycling end-of-life systems like batteries, we need to take advantage of these waste streams or unconventional resources. We have efforts to characterize these, but we also need to get technologies commercialized and to scale. And that's something that my office is focused on. It's what the notice of intent we released last week really aims to target. Getting pilots demonstrated for more feedstocks will really set up the ability to get multiple feedstocks to commercialization. And it's really an important part of diversifying the sources of critical materials that we have and enhancing our supply chain resilience. But in addition to these unconventional resources, we do need to also look at new and innovative solutions for hard rock mining. And that's also something that you'll see a focus from our office going forward. Thanks.
Thank you, Ryan. Wadad Whitman will take the next question. Wadad, from an American company's perspective, will DOE be monitoring for foreign entities of concern post-award?
Yes, thank you so much for the question, Karsten. Yes, that is a critical component of my program. We are investing taxpayer dollars to meaningfully shift global energy supply chains, and we want to prevent adversarial entities from undermining or circumventing our efforts. I will add that we also work very closely with our U.S. government partners, particularly the Pentagon and the intelligence community, in order to coordinate those efforts. But thank you for the question.
Thank you. And we've got time for one more. And for this, we're going to go back to Jen Schaefer. Jen, what role is ARPA-E looking to play in facilitating partnerships between recyclers, manufacturers, and primary material suppliers to reduce market risks and increase demand for domestic critical materials?
Thank you for that, Karsten. Yeah, so this is something that is critical for the execution of any of these successful efforts. And it's one of the things that we pull together when we are doing our program development, actually even our program execution. So you can imagine a scenario as one is developing a program, you're bringing in the various stakeholders that you mentioned, such that the way that the program is structured, it actually hits as many goals as practical with respect to the variety of different aspects that are in demand. Frequently, when you consider a space, you aren't going to be able to address everything with a single investment, but you can try to address as much of it as practical. Another piece within this is even once you get the stakeholders involved at the program development stage, you actually have the program execution. And one of the aspects that makes ARPA-E unique is a very active program direction cycle where the program director is very engaged in the program management, not only with respect to negotiating and setting the technical milestones, but also with the commercialization of the technology. And so you can imagine scenarios where you're bringing stakeholders in at timely points, helping them to attend various meetings that the agency has so that they can connect with a broad ballast of people that are considering this space. And so it's really basically an ongoing conversation in these types of dynamics.
Great. Thank you again, Jen. And thank you to all of our speakers for their responses to these thoughtful questions. We'll now hear two additional presentations from the perspective of DOE-funded projects. First, we will hear from Paul Boniface, Director of Business Development at Rare Element Resources. Paul?
Hi, thank you very much. So I am Paul Boniface. I'm the Director of Business Development for Rare Element Resources, and we are a rare earth project based in Wyoming. And our goal is to develop and commercialize the upstream portion of the rare earth supply chain. Next slide, please. We are publicly traded, so this is the necessary disclaimer about forward-looking statements. And my part of the presentation will be sent to you afterwards, so you'll be able to read this in detail. Next slide, please. Here we are in a nutshell, right? I included a map because Wyoming is a sparsely populated state, although beautiful. We're right above Colorado, right below Montana. We're in the northeast corner of the state, and we have two parts of it. We have the Bear Lodge project, the Bear Lodge deposit, which is a rare earth deposit that is rich in magnet materials. And then we also have a separation technology, a proprietary and state-of-the-art separation technology, which has culminated in a demonstration plant, a commercial scale demonstration plant in Upton, Wyoming, which I'll talk about here soon. What we're trying to do, like I said, is the upstream half of the domestic supply chain. So we would go from mine all the way to separated rare earth oxides, with our main product being NdPr oxide, or neodymium praseodymium oxide. We're publicly traded. Depending on the day, I think we're around $500 million market cap. We are in Wyoming, and we've been around for a couple of decades now, investing over $170 million in both the deposit and in the separation technology, along with our tech giant partner, General Atomics, who you may know as one of the largest defense contractors, private defense contractors in the United States. Next slide, please. This video, I'll just talk over the video as it goes. So what you're seeing here is RER's $66 million demonstration plant in the small town of Upton, Wyoming. It is state of the art, and it's expected to produce 10 tons of commercial grade NdPr oxide in 2026. And this is leveraging the proprietary technology that we have developed alongside General Atomics, who is also RER's majority shareholder affiliate. This demo plant is very much industrial scale, and it was supported by a generous $24 million grant from the DOE, as well as $4.4 million from the state of Wyoming. RER's separation technology, in a nutshell, it has higher efficiency, and lower costs. So it's really bringing the technology that was originally developed in America for separating rare earths and then over the decades moved to China, where the innovation pretty much stopped. They just kept repeating the same tried and true methods that were great in 1950, not so great today. So we're really taking an efficiency and a step change here. Like I said, this facility will produce 10 metric tons of commercial grade NdPr oxide, but the goal here is commercialization. It's all about commercialization. And we are targeting 2,000 tons per year of high purity NdPr oxide by the end of the decade. That is our goal. So next slide, please. This is pretty much everything I just said. That way, when you download the presentation, you can have a reminder. Next slide, please. So a little bit about the deposit itself. Our rare earth deposit is called the Bear Lodge. It is north of a little town called Sundance. And if you know your Western outlaw history, you might remember Butch Cassidy and the Sundance Kid. Well, the Sundance Kid was from Sundance, Wyoming. So the Bear Lodge deposit was actually discovered by the USGS decades and decades ago. And they recognize it, and it is recognized as a world-class deposit of rare earths. Now, I'm cognizant of the fact that pretty much every mining company claims to have the best deposit. We don't have the best deposit in the world. That's just not factually true. In fact, the only operating rare earth mine in the United States currently is Mountain Pass. And to put in perspective, Mountain Pass is somewhere between 7.5% trio, what we call trio. It's a total rare earth oxide. It's a way to measure the concentration of rare earths in the ground. So the biggest mine in the United States and one of the biggest in the world is Mountain Pass, and they have about 7.5%. We have about 4.5% trio. That is significant. As far as I'm aware, it is the highest concentrations anywhere in the United States of a deposit that has not yet been turned into a mine. If you compare that, that's very much 10, 11, 12 times more concentrated than any comparable hard rock rare earth deposits domestically or anywhere. And then though there's a lot of interest in coal, and we very much support unconventional coal as well as conventional coal, they're sitting around 300 ppm, maybe 500 ppm. We're about 45,000 ppm. It's over 100 times more concentrated than that. And so a lot of everything depends on concentration, metallurgy, and we do not have a concentration problem. We have fully delineated, fully explored. We've drilled tens of thousands of feet of core. We have warehouses filled with them. It's a very well understood and characterized deposit, and it is ready to continue permitting. We actually started permitting about a decade ago when then the price manipulation of rare earths started in China, and that had to be put on pause, but we're ready to pick it back up. Next slide, please. What you're going to see here is a time lapse of the construction of our rare earth demonstration plant. It's all about separation. Right now, you'll see by the end of the video that it's fully constructed. Spoiler alert. But right now we're in the rework stage. because this is a first of its kind innovative technology. And this demo plant that you're seeing, it was originally developed as an idea of a 12-month testing facility, 10 to 12 months. But we do have plans to extend the life of the plant for further rare earth progress, including heavy rare earth separation. And this plant that you see here, we will start those operations Q1 of 2026. As far as employment, like I said, we're in a small town, but the local employment has been fantastic. We've hired a local contracting firm to staff up the demo plant. We had 20 full-time positions, and those will continue for the life of the demo plant, which we're trying to extend, indefinitely. It's been a huge impact to the local economy. And I think people always kind of talk about, this is going to impact this, is going to impact that, we're going to bring jobs. But it really has revitalized this 800-person town. In fact, for the first time in decades, new businesses have opened in town, literally right across the street, a brand new hotel, which I stay at every time I'm in town. The costs of this demonstration plant, originally scheduled for $44 million. This was budgeted before COVID, and the DOE support was actually upped to $48 million cost share. And now the total costs of the project have surpassed $66 million, but RER has committed to funding it. So we are going full steam ahead. Next slide, please. And I think the final slide. There we go. So once again, Rare Element Resources, kind of a mouthful, not the most catchy name. So we go by RER. And our tech partner, General Atomics, are very pleased and thankful that the DOE and EERE, and at the time AMTO, have supported this project since 2019. We look forward to completing the plant's objectives and leveraging these existing investments to further the domestication of the rare earth supply chain from right here in Wyoming. Thank you.
Thanks very much, Paul. And next we'll hear from Frank Johnson, the Chief Technology Officer, Niron Magnetics. Frank.
Thank you. So good afternoon, everyone. Thank you for the opportunity to present. My name is Frank Johnson. I'm the Chief Technology Officer at Niron Magnetics. Go to the next slide, please. Niron Magnetics is commercializing the most powerful, rare, critical mineral-free permanent magnet on the market today. Our materials are made from abundant and clean raw materials. We are 99% iron and nitrogen as our input materials. Because of that, we do not have the susceptibility to supply chain disruptions for our raw materials, and so we could be manufactured globally. Next slide, please. Magnets are used in pretty much every part of the modern technology economy. We may be most familiar with them as things that we put on a refrigerator, but they are found in basically any application that transforms electrical energy into mechanical energy and vice versa. So motors, speakers, generators, and so on. You can find them in applications as diverse as your cell phone. A cell phone contains about 2 to 3 dozen magnets that are used for speakers, but also for things like the suspension of the optical components of your cameras. They are used in audio systems, both the earbuds that you might have, but also in professional audio loudspeakers. An automotive application, the largest quantity is found in a traction motor in an electric vehicle, but even a conventionally powered vehicle contains dozens of subcomponents that use rare earth magnet enabled technology, such as motors for pumps, power steering, actuators, such as the actuator on your trunk, as well as the audio system. And then finally, they're used extensively in defense applications. Many of the systems on modern defense platforms such as aircraft, land vehicles, and naval vehicles require permanent magnet-enabled motors and generators. Next slide, please. And as we know, at the moment, China dominates the supply chain for rare earths, which are used to make today's most widely available magnets, basically from start to finish, from the production of the rare earths, from the ore to the oxide to the alloy, and then finally to the manufacturing of the rare earth magnets from that alloy, and then increasingly the applications that use those magnets, such as electric vehicles and other applications. Next slide, please. Nairon has been around for about a decade. It was founded based on research that was funded by ARPA-E starting in 2010 in response to the first restriction of rare earth elements that appeared from China. There was a project called REACT funded by ARPA-E that funded several teams looking at alternatives that did not use rare earths or use less rare earths. The University of Minnesota team was the only team that was able to attract sufficient venture capital from that in order to start a commercialization effort. And so Nairon was founded in 2013. Next slide, please. The initial funding came from a white space firm, Artemy, and it was based at the University of Minnesota for several years. In 2017, we made enough progress technically that we were able to raise our first round of funding. The lead investor was Anzu Partners, a venture capital firm that specializes in hard tech. But we also have a group of investors, including the University of Minnesota, as well as the local Shakopee Mdewakanton Sioux tribe. The work continued at an industrial facility that we established in Northeast Minneapolis, where we explored the manufacturing technologies that were developed at the university to de-risk the core technology so that we could find a way to transfer the lab scale process into a scalable bulk manufacturing process. Next slide, please. Another key step along the journey was the selection of Nairon for a scale-up award in 2022. This was critical. This provided the capital that we needed to build out our pilot scale manufacturing facility here in Minneapolis. This also provided the non-dilutive funding that enabled us to raise a subsequent round of funding to complete the capital equipment purchasing that we needed to produce. And we are about to finish the ARPA-E award. And with this, we have been able to scale up our manufacturing capacity to about 2,000 kilograms of magnets per year. This is what we will use to supply the prototype samples that are needed by our customers, commercialization partners, in order to be able to proceed through their product and vendor qualification programs, ultimately leading to the supply agreements and offtake agreements that we would need to attract the funding needed for our next stage of manufacturing, which is our full-scale manufacturing plant. Next slide, please. So what ARPA-E enabled us to do was take our process from a very simple laboratory-based process where we had limitations in the quantity and the form and the size of the magnets that we could make. If you go to the next slide. We were able to acquire and install the scalable process equipment that we need to manufacture both the magnetic powder that is used to form the permanent magnet, as well as the specialized pressing and forming equipment needed to turn that powder into a bulk permanent magnet. And what I have on the slide here on the right are some examples of the permanent magnets that we are currently manufacturing and supplying to our customers today. Slide, please. This is our current facility in Northeast Minneapolis. We're actually about at 120 employees now. We've doubled our employee count pretty much every year for the last 2 to 3 years. This facility is where we started back in 2017 with about 10,000 square feet of space. Was expanded to 70,000 square feet. And we had our ribbon cutting ceremony a year ago. And as we continue to produce magnets for this facility, we'll continue to provide these to our customers, as well as be able to supply specialized lots for special orders. And this will continue to be the R&D facility for Niron as we grow. Go to the next slide, please. So what's next is that this year we announced that we will be producing or developing our first full-scale manufacturing plant in a town called Sartell, Minnesota, about 90 minutes drive northwest of Minneapolis, St. Cloud, Minnesota. At this facility, we'll be able to install the capacity of the equipment and the facilities needed to produce on the order of 1,000 metric tons of magnets per year. These will be the materials that we'll use to satisfy our initial customer orders. And it will also prove out the technology needed to build subsequent full-scale manufacturing plants by demonstrating the process operating at scale. Next slide, please. So I want to take this opportunity to thank our partners, both within the Department of Energy, the Department of Defense, but also our customers and investors as we've proceeded on this journey. If you'd like to know more about Niron Magnetics, there are our contact information, or you can reach out to me. Thank you.
Thank you, Frank. So before we conclude with a Q&A with both Paul and Frank, I just wanted to remind everyone that the Microsoft Forms link will be available for another 48 hours after the event. And again, this is voluntary, totally optional. The link is also provided in the Q&A section of your Teams view. You'll find that if you scroll down. A last activity for our workshop today is to share a few questions with our DOE-funded project speakers. So the first question, and Paul, I think we'll start with you, and then Frank, you'll follow. The first question is, what governance and decision mechanisms are needed to deliver an Operation Warp Speed style response in critical minerals without compromising technical rigor or fiscal safeguards?
I think commercialization timeline is indeed important. However, the viability of the technology and the project assets shouldn't be compromised over near-term goal of imminent production, right? That's the case with the RER demonstration plants, as the separation technology innovation should be front and center, even if time and funding is needed first before the commercialization of the project. Why? I'd say because while the conventional approach of separating rare earths can be more near term, I mean, they've done this technology for 60, 70 plus years. But the benefits of innovation in the technology in rare earth processing and separation has longer term benefits, which is what we're trying to do.
And from our perspective, something that would enable a warp speed style program, and it's kind of explained, I think a lot of the success that we've had is focus on a goal. In our case, it's the development of a rare earth-free compound magnet based on iron nitride. Because when you focus on that goal, it allows you to have the flexibility that you need in how to achieve that goal. And what types of, in our case, processing and other types of methods that we may or may not need to pivot to. And so then when you have the goal and the flexibility, then if you have the participation of your stakeholders, both in the government and on the customer side, then you can find the support that you need to achieve that in the fastest time, or fastest speed and minimum time possible achieved.
Great, thanks to you both for that. And Frank, I think for this next question, we'll start with you this time. What tools, infrastructure, and models are needed to scale promising technologies from concept to prototype to pilot and validate them for broader adoption?
Again, looking at our example, we have a product that is a component typically of a larger system. So what we've been able to do is use tools like computational methods, both in simulation of materials, but and also machine learning methods that we can use to try to understand what the performance of our product would be before we were able to scale up the product to the level where we can provide prototypes. This allows us to work at a much earlier stage with our partners so that we can work with them to understand how best to use our material in their application. And then, other needs are the data that you have to generate in order to feed those simulations. And this is where collaborations with entities like national labs is very valuable because of the scientific work that's been ongoing for many, many decades, but also the specialized facilities like computational and characterization facilities needed for an advanced material project such as ours.
And on our sides, especially in terms of infrastructure and models, the huge benefit that China has, for example, is that they are a non-market economy, and their government has support mechanisms to be able to heavily subsidize industries that at the onset may not be completely economical on their own, but are important for many reasons, including a national strategy or national defense. So for us, scaling RER's Bear Lodge project was helped immensely by the DOE-backed infrastructure like our demo plant, because that serves as a bridge from pilot to what we're shooting for, which is a 2,000 ton per year commercial NdPr oxide production by the end of the decade. And that addresses the upstream mining to oxide needs. So the infrastructure, like our $66 million plant, generates operational data and economical data that de-risks it towards bankability and commercialization.
Excellent. Thanks again to you both. And our last question today, Paul, we'll start with you again for this last one. How can we accelerate the identification and early stage testing of solutions to critical mineral and material challenges to enable fast iteration and informed failure?
Yeah, I think it's kind of a combination of the answers I gave previously. So, it's really, our plant shows how targeted DOE supported projects can validate proprietary technologies. I said, over $24 million from the DOE in cost matching funds have already been committed. And that really allowed us to accelerate from lab to near operational status, set to commence operations in a few months, early next year. And, by focusing on high concentration deposits like our Bear Lodge deposit, I think we align with DOE's goals to secure domestic supplies and reduce reliance on foreign sources while incentivizing and promoting more efficient, environmentally friendly, lower cost methods.
We've benefited greatly from the model that ARPA-E and DARPA established, and how to seed and develop advanced technology programs at a rapid pace. And that's been through having defined milestones, participation from our sponsors on an active basis, and very robust two-way communication between us and our government sponsors, because that allows us to pivot where we need to pivot, get guidance where we need to get guidance. And also, it's been critical for us to have support from ARPA-E at critical points in our journey, both at the very beginning, but then also with the programs like the Scale Up program, because that provides the capital needed to get to a level of scale where capital may not be as available from just the private market alone.
Wonderful. Well, thanks so much, Paul and Frank, for your presentations and for the Q&A. And for the workshop today, that wraps up our agenda. On behalf of the DOE team, thanks to all of you who have attended the workshop. We know you're very busy and greatly appreciate your time. Thanks also to our impressive group of speakers for sharing their comments with all of us today. 2 final reminders. The Microsoft Forms link will remain open for 48 hours following the event if you'd like to provide your inputs. And the recording of this event will be made available on DOE's YouTube channel. That concludes our workshop. Thanks, everyone.